I just started.
Okay, cool. Hi, everybody. This is what month is it? April Vorum Databricks user group. I'm Spencer Cook. I'm a Databricks solution architect champion, Vorum Reply senior data scientist, and the host for today's session. We're going to be talking about Databricks 101 today, sort of talking about what Databricks is, what it's useful for. This is a session that we did around this time last year, maybe a couple months later. But I really feel like the content within a Databricks 101 presentation is changing on basically a monthly basis with the velocity at which Databricks is releasing new features and the semantics of like the data lakehouse, things within that domain are changing. So I thought it would be good to do something like this again. A lot of the content today is going to be demo focused and sort of discussion based, a Socratic seminar, if you will. So one of the things that might be helpful to get started is to just kind of go around and let's talk about our exposure to Databricks. I'm not necessarily going to call on, names unless you want me to, but if you guys would just volunteer and sort of give me an idea of what level of comfort you have with Databricks, what things you've been, curious about lately in regards to the platform or some of the paradigms around it, and just give me a feel for how I can help you out with the basics of Databricks.
So I'll start. To me, it's something that you mentioned about the velocity. So I think what I've seen is Databricks has become the go-to solution. Mm-hmm. But because it's become the go-to solution, it started to have these tentacles of solutions start to appear that really consolidate together to an overall solution. And I haven't been able to put together how all of those pieces fit together. So really for me, it's understanding what Databricks in its current state is capable of and where they're going with their future releases and how that integrates with our overall solutions.
Perfect. So you need 101, 102, and 103. I'll make a note. Okay, anybody else?
I'd like to say that, I'm not, obviously, I'm a PM, so I'm not going to be,
sure.
Doing much dev work or anything, no dev work to speak of. But as somebody who's a fairly technical PM, I like to understand the products that I'm implementing or managing the implementation of, right, so I can participate and whatnot. And my data, I have a lot of data experience, but it's all from a long time ago, when we were just doing data warehouses and managing ETL process and SSIS and all that. And so I know that I have a lot to learn and ramp up on. So I'm looking forward to this to just get a better feel for where Databricks fits into that entire pipeline, just in general, and then obviously in the context of our solutions that we're going to be providing to customers. So.
Right. Yeah, it can be very helpful to explain why your warehouse is now sitting in the middle of a lake. No, Chris makes a great point. I think even for people who aren't implementing Databricks, a lot of these paradigms are here to stay. Whether you're using Databricks or Spark in an on-prem solution, or if you're using, the managed deployment on something like Azure Databricks, really understanding the capabilities and limitations of the platforms and how to communicate that to customers is one of the biggest challenges we face, because so much of this, it's not that it stagnates, it's that you have these different, sort of epochs within any technology. And when you reach a major paradigm shift, it's not like there are people walking around handing out pamphlets saying, hey, here's, what the new world is going to be like. And so it can be really valuable, I think, for everybody to sort of get a baseline. So that's great. I see we've got a couple of new people that joined. So we're just kind of going around. Today's topic is Databricks 101. So we're just kind of going around sharing, what we'd kind of like to cover in today's session, and if there have, been any recent blockers, sort of our relationships to Databricks. And not everybody has to speak. I just want to make sure that, we get a good baseline for, I don't want to miss out on anybody because, we only do this about, or a 101 about once a year. So just wanted to make sure and get any topics collected.
I think
Cool.
for me, it would be mostly like being able to analyze the data with Databricks, being able to do some display the data with data frames, like the basic. Wanted to at least start off with the basic, dissecting, viewing the data analysis with Databricks, setting up that notebook. Probably will also be helpful for me.
Awesome. Yeah. So that's more on the technical side, which is definitely where I like to hang out. So that'll be awesome. Thanks, Henry. Okay, so if we don't have anybody else, I think we can go ahead and just hop in. Cool. So, just from a non sequitur perspective, when we ask what is Databricks, this is Databricks, right? Specifically Azure Databricks. But, they're even in this, basic or introductory UI, their sort of home screen, there's a lot going on. So one of the things I want to talk about at a high level first is, what is it beyond just a web application or sort of a web-based IDE that data developers can use, right? Because that's obviously one of the big selling points when people are, even people at Valorem are going into other customers and saying, your data scientists are going to love this, your data engineers are going to love this, even your admins, it's going to be easy to use. What does that mean? What does it do? There's a lot of things that are really easy to use, but it's not clear what the value add is, right? Or what it is that they accomplish in that ease. So one of the main things to consider when you think about Azure Databricks in specific is that it's just a hosted version of Apache Spark. It's just an analytics platform based on Apache Spark. And I'm going to drop a link in the chat. I'm going to just keep some notes as we go. I think it's a little bit more intimate than a deck. So one of the things, if you see that architecture at the top, it just kind of covers what you can accomplish within Databricks, right? And you can see that it's pretty comprehensive. But the main thing to notice is that it's all running on top of Spark. So going back to, our sort of audience Q&A, anyone brave enough to take a punt at what Spark is? So Spark is essentially just an evolution of Hadoop. That doesn't really tell you much, right? So Hadoop is basically, think about Google file system or Azure data lake storage or even blob storage, S3, Amazon S3, things like that. They're all actually running on top of the Hadoop file system. So Hadoop is essentially the first distributed file system that was invented in the late 2000s or the aughts, if you will. And that led to this technology called MapReduce. MapReduce is a software engineering paradigm or, a development paradigm similar to things like, functional programming or dynamic programming. And it's essentially just a consistent approach to solving problems, but it specifically works really well on distributed systems like Hadoop. And so what MapReduce essentially accomplishes is it just does a bunch of different tasks that can be distributed. So say, for instance, I wanted to do a MapReduce task to count the total age in the user group right now, right? Essentially, I could give each of you guys the task of putting your age on a piece of paper. That's the mapping, right? It's assigning an element to each person. And then what the reducing step does is just goes to those groups and consolidates the result and returns it, right? So essentially, that's what Spark is doing at its core. It has just optimized and tuned that to where we can do certain things more effectively. So for instance, let's say that I did that map reduce task in the April user group, and then I do it again in May, right? And a certain subset of the users are in both groups, right? And let's hope, fingers crossed in May, maybe we have some new people, right? What Spark can do is store things in memory. So if I notice, hey, I've done this calculation before, I already know the total age for the people who attended in April, you don't have to recalculate that. So that's all Spark is doing. And all Databricks is doing is just hosting Spark on a particular cloud provider. And so in our case, we focus heavily on Azure, right? Now, Databricks is on all three major cloud platforms. It's on Amazon, and it recently released on Google Cloud Platform. So when we think about Databricks, just think about hosted, enterprise quality Spark. Now, the advantage of Azure Databricks is that it's tightly integrated with Azure. So you get streamlined workflows, you get interactivity, and that's really what people talk about when they talk about the value add of Databricks as a development environment or as a platform, right? Because far before Databricks was even on the radar or even a company, places were developing their own Spark workloads. They were hosting, Spark instances. Think like Amazon's Elastic MapReduce, even Cloudera, right? They were all based on Spark. And so really the value out of Databricks is taking the best in class versions of Spark in what they call the Databricks runtime and hosting those on Azure and making it tightly integrated with other Azure tool sets. So that's what you should think about when you think about Databricks and when you think about Spark. Now, within that, we have a couple new things on the horizon. I don't believe that it was available the last time I gave this talk. Down here, there's now an app grid. So when we click on this, we see the Databricks Workspace and Databricks SQL Analytics. So Databricks Workspace is essentially your set of, notebooks, your entry point into doing machine learning, cluster management, all of your traditional data engineering and data science workflows, right? And that's where I live 99% of the time. Let's pop over to SQL Analytics. So this was announced at last year's Spark conference, and it's one of the biggest new features since I've been at least involved in the Databricks community. Notice, this is more focused around things like queries, dashboards, alerting, and creating SQL endpoints. And so essentially, this kind of closes the gap of the data warehouse or data lakehouse piece. So when you're working with teams of people that aren't going to be coding in PySpark or Spark SQL, right? And they're going to be more consumers of your data. This is a great environment to be in. So, you get pretty easy access to dashboards. Like I can, I don't know if I have a cluster live or not, but I can see Power BI dashboards for some of the data that I've loaded in. I can create queries ahead of time that I can serve to my users. Essentially, it makes it so that you platform without being a data engineer or a developer. This is still in preview. I believe it is now in public preview, but this is going to be something that's very much on the horizon when we talk about Databricks over the course of the next year or more, especially as it relates to working with customers that are coming from more of a traditional data background.
Spencer?
Yes.
You're kind of cutting in and out a little bit. I don't know if you can adjust anything.
Yeah, I think I can. Let me, because I noticed a clicking too. Let me make sure my microphone is good to go. Here, 1 second. Okay, is that any better?
I think so.
Okay. Yeah, please let me know if it continues to be an issue and I can switch over to a different microphone.
Hey,
Okay.
quick question,
Yes,
sir.
yes.
Is there like a place where we can access an environment that we can use to follow along, like a Databricks environment that is already equipped with object?
So without knowing which specific subscriptions you're in, there is not. That's a great question, though. What I would recommend anybody do is go over to, in chat, you'll see the Databricks Community Edition. I just posted a link. And that is a free environment where you can set up a Databricks instance and go ahead and play around for free.
Thank you, sir.
Yeah, of course. And then reach out to me after this meeting and we can figure out some specifics around your Azure subscription. If you're a member of like the Microsoft Partner Network, then through your Visual Studio Enterprise account, you should get, I think it's like $150 a month of Microsoft Developer Network credits. And that's what I'm hosting. Like I can show you the workspace I'm going to demo. It's hosted on my Visual Studio Enterprise subscription.
Okay, thank
so
you.
That's what I would recommend. Okay, so within this environment, this is sort of where you kick off all of your Databricks work, right? So, you know, we've kind of talked about what it can do so far in relation to this, where is it? You know, this Databricks workspace tool, right? We see that it can work with data scientists, data engineers, and frontline of business people. It can do deep learning ML, it can do streaming, data warehousing, Power BI, and it interfaces with all of these key Azure components, right? So let's look at some examples of how we accomplish things like that. So Henry, I remember, asked about how to set up a new notebook, right? So let's go ahead and start with some common tasks. So if we click New Notebook, we'll see a couple options. So we'll go ahead and give our notebook a name. Think about this in the same way, like when you were in grade school and you flipped open to a new piece of paper in your notebook, right? You might just put a name at the top of the title. It doesn't have any meaning beyond that. It's purely an organizational thing. Now, another thing you'll notice is we have a default language option. So Databricks Runtime via Spark has 4 language APIs. So we can choose to have our primary language be Scala, SQL, or R. And then we'll leave the cluster as default for now. We'll get into clusters later. So when we create this, we just get something similar to like a Jupyter notebook, right? Where we have these different cells and we can run code. Since this is Python, you know, we always have to start everything with hello world, if I could type. And we'll see this basic output. You'll notice when I run this, it automatically creates a new cell. You can also create new cells by clicking the new cell button. And there's plenty of keyboard shortcuts available, similar to any good IDE.
Hey, Spencer.
That's
Sorry, your mic is just kind of cutting in and out.
okay. Let me unplug and replug it, okay?
Okay.
We'll see if that helps, because I'm I'm getting some fuzziness on my end as well. Let me turn down the gain. How's that, Lindsay?
Seems to be better.
Okay, just keep me in the loop. Tech, right? So you'll notice here, I get, autocomplete features similar to like Visual Studio Code or something like that, right? Another thing worth calling out, when we set our default notebook language, which we can confirm up here that it's Python, we can also change it. Not all is lost. So if we want to use one of the other languages, we can simply add what they call a magic command to the beginning of a cell. So if we want to, work in SQL, I'm now in SQL. Okay. And so there's a lot of flex about notebooks. Think about them as organizing a particular task. Don't think of them in terms of, languages necessarily or specific boundaries like you might think of, a file in a normal programming workflow. Think about it as a particular task. I typically organize notebooks per piece of data. Like if I'm going to be working on a particular table, I might work end to end on that piece of data in one notebook, and that might entail Python tasks, SQL tasks. Maybe you have to even pop into Scala or R for certain things. So this is a notebook. Within a notebook, we can also do some more advanced things like set permissions. We can also enable comments. So if we select a particular notebook cell and select some code, we can comment on it. So this is fine. Why not just comment inline, right? Well, the reason is if you had another user in your workspace, they can actually collaborate and type in the same notebook at the same time. So you'll just notice an icon above that shows that another user is in the workspace. And similar to other collaborative environments like Google Docs, different people will get, different colors. You can also leave comments for each other. And you can also see in the revision history, who did what. These changes I'm responsible for. If, Scott or Henry was commenting, it would show a different color, what they had typed. So those are some of the features of notebooks. Any other questions around that? Or is that making sense?
Yeah, it's making sense. Thanks, Spencer.
Okay, awesome. So yeah, so there's quite a bit that you can do within notebooks. If you go in the file, you can see that we can upload and export data. We can also move notebooks around, clone them. There's different advanced editing features. So I would recommend just setting up that community edition and playing around with some of that yourself. But really, it's just as extensible as most development environments you might be used to, like Visual Studio Code or Visual Studio.
Yeah, can you maybe quickly show us a couple of maybe top common commands like, head or take, one of those commands that allows you to visualize data real quick while you...
Yeah, that's what we're going to look at next, actually. So you read my mind. So let's go back home. So the next thing we're going to do is import some data. So we can click Create New Table. Now we get a couple options here. So we can upload a file, which is what we're going to do. You can also target a Databricks file system directory. You can also connect to some native connectors like Blob Storage, Data Lake Storage, if you have a JDBC store, Elasticsearch, things like that. And there's also some partner integrations. So if you're working with data coming in real time from Qlik or Fivetran. So let's go ahead and upload our file. So I believe mine's on the desktop. So this is some data I've been working with in my weekly sessions. It's a JSON. So let's go ahead and create the table with the UI. We'll look at the notebook next. But especially for beginners, making it with the UI is a really common pattern. So let's go ahead and preview this. And we'll see a couple things. So it's generating a preview of the data because it's kind of parsing through it, and it's doing schema inference. So you'll notice within the JSON, which I'm actually going to go ahead and open up the JSON real quick just so everybody can see what's in there. So it's just standard JSON, a bunch of records on one row, you know, objects or keys and values. And so what Databricks is doing is walking through this and inferring the top level objects and some of the schema around them, right? So we can also turn on infer schema and force it to infer types. So let's check.
Spencer? Okay, sorry, I thought you cut out.
Hey, can you guys hear me now?
Yes.
Yes, sir. Yeah.
Okay, I'm just gonna hang out on my headphones and not worry about video for now. I think I'm running into an issue with my USB hub, so I'll have to replace that later. Okay, so let's get back into this. Thanks for the heads up, Lindsay. So let's get back into this. So the infer schema is just forcing it to, you know, like I said, infer the schema. But it looks like this all got read in okay. So let's go ahead and create our table in Notebook. So we have this option to go ahead and just create it with this name. I want to go ahead and show the code too. And this is going to get into, you know, Henry's question from earlier. So this is going to show us how to create and query a table or data frame that we uploaded. So we see the file location is now in this file store. We have a type specified and we have some options created. So this created our data frame using spark.read, and then we specify the format, in this case is JSON. We tell it to infer our schema, and then we go ahead and run load on this file location from the Databricks file system. And then this creates the data frame, and finally we can display the result of that, and we can see our beautiful data here. We can also see the schema of the data frame that got created. So we can see that it has a struct under badges with some deeply nested data types. So if we went ahead and cracked this open, we can see that. So, you know, count is coming in as a long, items is actually an array. So we have items 0, 1, and 2. So that's how we read in data. Now, one of the other things we can do if we wanted to make this easier for other users to work with is go ahead and register it. So we can create a table name or a temp table name, and then a command from within that data frame is to create or replace a view. So we'll go ahead and register this table. And then in SQL, notice we're using the SQL magic command because this is a Python notebook. We can do a select star from this view, and it will return the same results from above. Similarly, if we wanted to register it as a permanent table, we can give it a name. And then notice this is similar to what we were doing above with spark.read. This is actually writing. We're going to write it out in the format of Parquet, and then we can save it as a location, and then this will register it within Hive. Hive is this table record that, think about it like a schema, like DBO or staging within your SQL server. And it just keeps track of what tables are registered. So we can have different databases and we can have different tables within that database. I'm going to leave this unregistered because, you know, it's just a demo, but that's a basic way to register it. So any questions about that so far? Okay, good. So that's kind of at a high level what we can do. I want to show off a couple more things here from our actual data lakehouse that I've pre-built. So I'm going to go back over here to one of our stages. So I want to show off a couple components of our ELT pipeline. So this cluster isn't running right now, so I'm not going to run these commands. Actually, I think this one I can run on Spark 3. There's some components, like some libraries that aren't yet supported on the newest version of Spark. So I just had this running on a older cluster. So I'll go ahead and import some of these pre-built commands. Now, one thing I want to point out is you see this run command. Notice it has the same syntax as the magic command we talked about earlier to run, you know, SQL. There's also some pre-built commands for managing Databricks itself that are magic commands. So in this case, run allows us to arbitrarily run a notebook. In this case, it's under utilities and then parameters. So this is what's hydrating our secrets to connect to the external data source and also to our data lake to write the data. So that's a pattern you'll see pretty commonly. We also register some of our paths for the data lake. We'll go ahead and print them out just for validation. And then I'm going to go ahead and hit an API to get some data. In this case, it's this untapped API. That JSON I showed you earlier, it actually came from this endpoint. I had just saved it in my data lake and then saved it off so we could manually upload it. And we can see some of the results from that here. So we'll go ahead and run this to download the rest of our data from this endpoint. And then Henry, I believe earlier, was asking about .head, for instance. So I've got this help in here so you can see what we're doing down below. DBUtils is a library from Databricks. It stands for Databricks Utilities. Within that, we have a file system object, and it has a method for put, copy, remove, everything that you'd expect in a standard Linux file system. So essentially what we're doing here is we're putting this data, we're putting this data that we just loaded in, that we just read in from this API into a file path. So we're actually using just the underlying Linux file system that Databricks is running on top of in the virtual machine to move our data. So it's very similar to, you know, your oldest type of ETL, you know, with things like cron jobs and such. And then we're actually going to use the head command to read from our schema path so that when we read the data, it's going to be read against the schema that we're storing in our data lake. So you'll notice here, oh, and I think I didn't read in data for this day, so I won't worry about that. But if we went over to our data lake, one of the things that I suggest that people do as a common pattern is go ahead and store your schemas as part of your data lake. And so if we were to download this and preview it, what you'll see is very similar to what we were doing before with the infer schema, is just now strictly typed. So instead of it inferring the schema every time we read in the data, it's strongly typed. So that's another powerful feature of Spark, is the ability to keep your schemas very consistent. So is that making sense so far? So then once we've read it in against the schema, we'll write it back out as a Databricks Delta table against this path, and then we're done. So that's a basic way of extracting some data, transforming it by applying a schema, and then loading it back into our data lake. Now, one last thing I want to show, because I know this has been a lot. So this is the raw data. So if I went in, to April 21st, you can see this is the JSON data that I wrote out at this line, this raw path, or sorry, at the put, this raw data, that's the JSON that we wrote out. When we wrote it back out with the schema and the Delta format, that's actually being loaded here. So you'll notice this is a bunch of Parquet files with a Delta log. That's because this is actually one big table. So underneath Delta, we only have files. Underneath raw, it's sorted and organized by date, right? Because this is only the records for the 21st, whereas this Delta table is actually a table that has everything so far. So again, I know, that's a lot. We kind of went from notebooks down into the deep end pretty quick, but hopefully that gives you an idea of what we're talking about when we talk about Databricks. I want to go ahead and leave the last little bit for questions, sort of, a little office hour. So any questions about Databricks in general or the topics we've covered in today's session?
I do have a very broad general question, and it's something I've seen pop up again and again and again, and it doesn't really seem to matter if it's engineers looking for the ability to process large data sets, or if it's data scientists looking to run large models. It feels like with the growth in data and the need for performance, everybody, no matter what area they're in, always finds that they're limited by something, and they progress to Spark. So Spark seems to be the answer that doesn't have the same limits that their existing tools have.
Mm-hmm.
Just sort of wanted you to expand on that a little bit. Like, is Spark the only tool? Is it just the most robust? Why does it seem like everybody is progressing to Spark as their answer for kind of all questions that have limits in their current state?
So I think what Spark is really adept at is taking garbage and making it somewhat manageable. I know that sounds kind of dry, so let me explain. So essentially, Spark, because it can scale out horizontally and vertically, by which we mean not only can you add more clusters to the pile, but within each of those clusters, you can increase the concurrency and volume of data. It makes it very easy to overcome hurdles that previously would have taken a significant amount of engineering time. And with a Spark cluster, you can go in and just dial in a certain number of nodes, right? Whereas to get an engineer that can squeeze, 1% more performance out of your existing, whether it be Hadoop or your existing, relational database system, that can be way more expensive than just some Azure resources, right? And so I think Spark has really presented itself in that way. And then once you have gotten over that hurdle and your business is sort of saved, right, or you're able to accomplish that value proposition that you're pursuing, then you can turn around and it gives you the tools to tune it within an inch of its life, right, and make it highly performant. So in the same way that we transitioned from, you know, Unix to DOS to Windows, and then it kind of just stayed Windows for a really long time, I think the Spark style paradigm is here to stay. Like there weren't really any issues with Hadoop or with MapReduce on their own. It's more how they, some initial engineering missteps they had or more oversights, right, that have now been cured. And I think it just has kind of given it enough momentum to stay around for quite a while. I don't think there's going to be another paradigm shift like Spark happening, you know, in the next 5 years or something. Does that make sense?
Yeah, that's kind of what I was seeing, is that we're at that inflection point where the paradigm need for something a little bit more than the existing infrastructure had to offer is really pushing towards a Spark type. And it just at this point doesn't seem to have any limitations.
So another thing that occurred to me that I left out of my main answer is how well it works with data lakes. So one of the topics that we're resurrecting is going to be around the data lakehouse, right? But there's some specific functionality around the way that Spark has been built from the ground up, around the assumption of using data lake as both your consumption and storage method, that makes it highly performant in enterprise use cases. So essentially, it's that magic bullet that a lot of companies have been waiting for, to be an excuse to finally go cloud native. And because it makes the transition cost so much less, then you can get people into the cloud, right? And then you're managing it on this platform that's, you know, constantly evolving, right? So I think it's hard to identify chicken and egg, but I don't think Spark would have been as popular without the advent of data lakes. And I don't think that data lakes would be getting as much usage if we didn't have Spark to make them so valuable.
That's perfect. I think something you said just really clicked, which is another reason why Databricks has grown so rapidly, which is it's unlimited in its size and scope, which generally puts it into, like, call it the big players club. Most of the time, traditionally, that'd be very, very expensive. And I think that paradigm's broken here because as a very, very small player, you can also get in at a very small scale, have all the benefits, but at a very small cost. So it's a very low barrier to entry with an unlimited scale.
Yeah, it's the equivalent of, you know, when you take an Uber Black to go get sushi or something, right? And you're like, oh man, I'm a high roller, because, you know, you're sitting in this, you know, black Cadillac or whatever. And then you get out of the Cadillac and you don't have to pay insurance on the Cadillac, right? You're not paying for new Cadillac tires. It's just, you know, no longer your problem. There have been many times where, you know, we're between a rock and a hard place on a certain solution. And rather than wait a week to try and figure the problem out, we take advantage of the scale, right? And just crank up some clusters for a little bit, ingest all that data very quickly. You know, one use case comes to mind that you and I actually worked on. There was that NLP problem, right? Where we were on a deadline to assign sentiment to a bunch of raw text records. And we did some napkin math and realized, like, wait, this is going to take a week. Well, we were able to scale out and increase the amount of concurrency and increase the number of clusters. And it was done in what, like 7 hours, to label something like 50 million rows of text data.
Yeah, so just for clarification, we expected it to take 7 hours for 2 million rows, and we ended up getting the results back in just a little over an hour. We paid for it, but I think that's the trade-off, is that we were able to get those 2 million records processed in a little over an hour rather than a week.
Well, and what I want to be clear on is there's so many instances of older platforms where paying for it isn't even an option. You know, you can throw all the money you want at your, HD Insights instance, and it's not going to, complete the circle. So it was a combination of good engineering on our part and Spark's flexibility that made that possible. And I don't know that it would have been available on other platforms.
Yeah,
one thing I want to call out real quick, cost-wise, and this is probably especially relevant to some of the salespeople or PMs in the room. There's a new option within the Databricks tools that came out recently called Spot clusters. So essentially, it's kind of like buying, your day-old bread at the bakery or the bruised produce, where you're using exclusively leftover Azure compute, and it's a like 10th of the cost. And so there's now an even more extensible paradigm around that, cranking up the cluster idea, where you're not even paying premium dollars to get that scale. You're literally just taking advantage of leftover cloud resources and using it to, solve problems even quicker.
What's the downside to that?
It's less predictable. So
Okay.
if you have an ETL that needs to be done by 5 a.m. for your Power BI refresh to kick off, do not use Spot clusters.
Okay.
But if you're sitting there with 50 million records of data you need to label by Monday, and you don't want, your stakeholder to have a mini heart attack when they see the Azure bill, then this is a great way to balance between the two and squeeze out as much performance as you can while doing it at, relatively budget rates.
And does all this kind of eliminate the need or lessen the need for being efficient in the, efficient in the query process or in the ETL process? Like I think of back in the day, like, there, and I won't say how long ago it was, but it was a while
Right.
ago. When I learned like database analysis and design, and there's hard limits to how many joins you want to do in a query, and we used to have to do all kinds of tricks to do temp tables, and if we had a really let's say we had a really complex view we wanted to create with a lot of different.
Right.
Does this eliminate the need for all of the mental gymnastics, or does that still happen, but earlier on in the process?
It changes the priority in my mind. And that's a great question. So I want to mention something back on Scott's point, that I think the reason Spark is so popular, they have just a world-class automatic query execution engine and performance optimizer. So I think there have been less times than on any other platform I've worked with where I look at the execution plan and think like, either I don't know what that's doing, or I could maybe do it better, right? They've just really optimized the crap out of that. So instead of paying again for a bunch of engineers that are well tuned with optimizing Spark, you can pay for a platform or a as a service model where you have literally the guys who created Spark doing it for you. And so that leads back into your question, Chris, where I think what it does is makes it easier to get from idea to POC to production quicker. And then once companies start to see, oh man, this works, I see the vision now, I understand, then it's a lot easier to have the conversation about going back in and tuning it and lowering costs, right?
Monkeying around with indexing and all that stuff.
Exactly. Yeah.
Okay, gotcha.
But with a well-tuned cluster pool, you can really get high performance without as much cost as is advertised, because you're only using the clusters as needed, right?
Yeah.
And especially with Spot, you could have it run overnight on commodity hardware and then show the client in the morning, hey, this is what this thing would look like at scale with, you know, terabytes of data and hundreds of clusters. Isn't this awesome? And they buy in, and then, you know, you move into, okay, so we're going to do this, and we're actually going to save you, you know, 20% off the estimate because we're going to, you know, partition it this way, tune it this way, but it makes it achievable to do it without that for your POC and for your, you know, your prototyping.
Well, and Chris, just to add some more color, maybe a question that you weren't specifically asking, but it's not magic. So solid engineering principles still apply.
Sure.
And
Yeah. Okay.
in some sense, your caution has to be a little bit more front of mind, because you do have so much ability to scale out that if you have poor practice, it will try and attempt to scale out. And I actually recently was on a project where somebody did a kind of ridiculous cross join with a couple hundred terabytes of data, and Databricks did it, but the client ended up with a $10,000 bill.
Wow. Yeah.
Right. So yeah, you're right in the sense that it's not this magic safety net. It's just that it basically matches you in a lockstep, where if you're doing relatively sensible things, you have relatively well organized data. You're not, you know, even if you're trying to do a skew join, you know, it'll fix that for you. But Scott's right. If you're doing things that you shouldn't do on any platform, this isn't like the one platform in the universe where cross joins aren't a bad idea, you know?
Yeah. Awesome. Okay. It's good to know. Thanks.
Cool. Any other
Hey,
questions?
Yeah,
Yeah. Hey,
Spencer, just
Henry.
two quick questions, right? Number one, I think Microsoft still owns Databricks. Now that it's on every platform like Google, GCP, like you said, AWS, is it still owned by Microsoft or no, it's not?
So there were talks early on for Databricks to be acquired by Microsoft. They decided to continue as their own company in like late 2018. But
Thank you.
they
Thank
were
you.
one of the first, they were on Azure first, and it was one of the most robust deployments. I still think to this day, it's probably, you know, the most scaled out platform, and definitely the one I'd want to work on.
Thank you. And then the last question I had, is there a link that you can send me that could easily help us set up a job in Databricks?
Yeah, so in that documentation, or that link I sent to what is Azure Databricks Workspace, if you go up a level where it says Azure Databricks documentation, that's actually Microsoft's documentation for Databricks. And so a lot of it is developed in collaboration, but you'll see that it covers nearly everything you might want to know. There's even how-to guides depending on your role. So like you could jump into the data engineer segment, and it's going to walk you through what Delta Lake is, some introductory notebooks, data ingestion, reading and writing, all that good stuff. So that's where I kicked off, was just through the Microsoft documentation. And then there's also some platform agnostic stuff from Databricks themselves, but I think the Microsoft stuff is where you want to be.
I think it's worth noting that the documentation is really good. A lot of people enjoy picking up and working on Databricks because they have access to really solid documentation.
Yeah, and they've scooped up some of the best curriculum developers in tech around to help them write this stuff out. So it's really good. And I just dropped a link into that specific page I was talking about. Cool. Well, I bet a lot of people have meetings at half past the hour. So I think we'll go ahead and wrap it up there for April. Thanks everyone for attending this session on Databricks 101. You're more than welcome to drop me a line via Teams or email if you have any further questions. But thanks for attending, and I'll catch you next month.
Thanks, Spencer. Appreciate that.
Yep. Thanks,
Bye-bye.
everybody. Bye.
Thanks, Spencer.
Thanks, sir.